Hello everyone, welcome to all. Hope you all are doing well, students. So today I am going to discuss thermal stress and strain. This is the very important topic in strength of material subject. Very important topic. Okay, very important topic in strength of materials. Clear? So today we are going to discuss thermal stress and strain. Thermal stress and thermal strain, two terms are there. Okay, so listen carefully. First of all, this is the bar or rod. Okay, if we are going to heat with the help of any burner, so this is our rod having length L, and this is we are going to heat with the help of burner. So what will occur here? This rod will expand, freely expand. If we'll heat any material, it will expand. Okay, and if we'll cool any material, it will contract. Okay, so if we fixed this rod at one end, if we are fixed this rod at one end, and if we are going to heat this rod, if we are going to give a temperature, okay, so one is the temperature, that is rod temperature, and one is we are going to heat some another temperature. So two temperatures were there, so temperature gradient is there. One is the surrounding temperature and one is we are going to heat. Like surrounding temperature is 25 degrees Celsius and our temperature is 60 degrees Celsius. So what will be the temperature gradient? That is 60 minus 25 degrees Celsius. So del T term will be coming here. Okay, so if we heat this rod at one end, so this rod will expand freely because no restrictions will be applied here. No restrictions, no support, no rigid support here. Okay, so this rod will expand freely, and if this rod will expand freely, there will be no thermal stress induced in that rod because no resisting force will be there. Okay, because this rod is expanding freely. Okay students, this rod is in space. If we'll heat this rod will expand freely, so no thermal stress will be there, but thermal strain will be there. If we'll heat this rod, it will expand, so its length will be increasing, so tensile thermal strain will be induced here. And if we'll cool this rod, so its length will be contracting, so compressive thermal strain will be there, but no thermal stress in that rod is occurred. Okay students, so when thermal stress will be occurred in this rod, if we'll fix this rod at both the ends with the help of rigid supports, that type of supports that doesn't move, that will not move, that supports will not move. If we'll heat this rod, then this rod will try to expand, but two rigid supports are at two corners, that supports will not move. So what will happen? This rod will try to expand, but this rigid supports will be going to apply here compressive forces. Compressive reactions will be induced from the rigid supports. Okay, so compressive reaction will be induced from the rigid supports, then resisting force will be induced, then thermal stress is induced in this bar or in this rod. Clear? So what will happen? If we'll fix, now this is our rod, and if we'll fix from both the ends, now we will heat with T degree Celsius temperature, and this is the length of the rod. So this rod will try to expand, but this is the rigid supports, and this supports will restricted this rod. So what will happen? Compressive forces will be occur from here. Compressive reactions will be occur from the rigid supports. So resisting force will be induced in this rod. So thermal stresses will occur in this case. Got it? Okay students, if the rod is going to be free to expand, then no thermal stresses will be induced. Okay. So suppose surrounding temperature is T1 degree Celsius and alpha is the coefficient of material. Alpha is the coefficient of thermal expansion. Okay. So this rod will expand freely if we'll heat with T2 degree Celsius, then this rod will expand freely. Okay, This is the free expansion of this rod. Suppose this rod is free to expand up to that point. Okay. Now I am going to apply here one rigid support. So what will happen? This is the expansion prevented. Okay. So what will happen if we are going to place a rigid support here, but this rod will try to expand outside to the rigid support. So thermal stress will be induced if the support will place here, and if the support, okay, now if we'll heat this rod, now if we'll cool this rod, so rod will be contracting will be takes place. So rod will be contract, so it will move in this side, so no thermal stresses will be induced. Okay. So rigid support, if we'll place a rigid support, then thermal stress is induced because this rod is trying to expand up to here, and the rigid supports is here, so thermal stress is induced in this manner. Okay students. So here alpha is our coefficient of thermal expansion, okay, or we can say thermal contraction. Okay students, alpha is the coefficient of thermal expansion or thermal contraction. Alpha is the sensitive to temperature variation. Okay, if alpha will be more, okay, so if we'll heat that material will expand more, and if we'll cool that material will contract more. So those material which have more coefficient of thermal expansion, those materials are very sensitive to temperature variation or temperature difference. Okay students, so alpha is our coefficient of thermal expansion. So what will be the free expansion? That free expansion should be, now first of all we will write strain. Okay, strain is directly proportional to del T. What is del T? Del T is the temperature gradient. In thermal stress problems, del T terms will occur. Why? Because one is surrounding temperature and one is the temperature we are going to heat on that temperature. So two temperatures were there. So temperature gradient will be occur here. So del T is our temperature differential or temperature difference or temperature gradient. So if del T will be more, so strain will be more, because if del T, temperature difference should be more, so material will expand more because heat is more, so our strain will be more. So we can write this equation, epsilon is proportional to del T, and this proportional sign will replace with the help of alpha. Okay, so is equals to alpha del T, epsilon is equals to alpha del T. Okay students, and what is epsilon? Change in length divided by original length is equals to alpha del T. So what will be del L? Del L is equals to L alpha del T. Got it? Del L is equals to L alpha del T. What is del L? Del L is the free expansion in that material. If we'll heat that material, the material will expand freely. That will be change in length. That will be del L. Del L is L alpha del T. Okay. Now, if the condition is this, we are putting the rigid supports and rod is there. So in that case, thermal stress is induced. And what will be thermal stress? Sigma is proportional to epsilon. This is Hooke's law. Sigma is equals to E epsilon. Sigma is equals to E, and what is epsilon? Alpha del T. So from this equation we can find thermal stress. Newton per mm square or Newton per meter square. Del L is in mm. These are the units, and this have no units. Strain is unitless. Clear? So I hope you understood this topic. Okay students, any problem? So this is our thermal stress and strain basic concepts, not at much higher level. This is the basic video. Now I will upload some higher concepts also after some time. Okay students, this is the basic approach. So simple approach is there. If this is our bar, and if we'll heat, in this bar is situated in space, if we'll heat, it will expand freely. If it will expand freely, then no thermal stress will be there, only thermal strain will be there. Okay. Now if we'll fix at one end, so again it have a space to expand freely. So again no thermal stress will be there. If we'll fixed at both the ends with the help of rigid supports, then we will heat, then it will try to expand, but rigid supports will offer compressive force or compressive reaction, then thermal stress will be induced in that bar. Okay students, now some yielding cases will be there, some cube problems will be there, that problems we will discuss after some time. Afterwards I will discuss those problems. So I hope you understood this topic. Okay students, write in the comment box if you will be having any doubt. Please like, comment and share videos. Okay students, thank you so much.